Dear students, today I would like to speak about how to generate random numbers using probability distribution. So we have two discrete distribution which are binomial Poisson and one continuous distribution which is normal distribution. First of all, let's learn how to generate random numbers using binomial distribution. As we learned before, that binomial distribution has two parameters: the number of trials, which is known in R as the size, and the probability of success, which is known in R as prob. So let's learn how to generate random numbers for binomial distribution. Let's see the first example we have. Generate 100 random numbers using number of trials equal to 20 and probability of success is equal to 0.45. So maybe I have missed here. I will write it. In order to generate random numbers, first of all, we need to set the initial points. That we can do by setting the seed. This setting seed will ensure that we will get the same random numbers when we run the code again. So first of all, before generating random numbers, we need to set dot seed. Let's start our seed, for example, with 1552. The next step is we need to know what is the command we use for generating random numbers for binomial. For random number, the command starts with R. Then the distribution we are using here is binomial distribution, so R binom. Open the bracket. If you can see, we have to enter how many numbers we have to generate, the size, which is the number of trial, the probability of success, which is known as prob. So we want to generate 100 numbers with the number of trials, so size is equal to 20, and the probability of success is equal to 0.45. In order to generate the random numbers, we have to run both code together. So the output will appear in the console window with 100 random numbers generated. If I want to save those numbers in the environment, I can just give it a name. Let's say x equal to, and when I run this code again, I need to run the set.seed with the second code for generating random numbers. So again, run the code. Now your x is saved in the environment, and x are the 100 random numbers which we have generated. So when you recall x, run it, you will get exactly the same numbers which you have generated before. Let's look at the question we have here. Display the fifth value in the generated data. So if we have saved our generated random numbers in the environment, we can extract any value of those generated data. So I'll just recall x, and I will say to the program that I want to extract the fifth value. So write 5. So x is a vector, and we want to extract the fifth element of the vector x. So the output will appear. What do you have in the fifth position in your x? We have 8. So when we run this code, we must get 8. So this is the way to generate random numbers. You need to know this code R binom, and you need to know that the parameter for binomial is number of trial, which is known as size, and the probability of success, which is known as prob. Even if you don't write size is equal to, we just write 20, this program will understand that In this position, you are writing the number of trial, and in this position, you are writing the probability of success. Now let's look at the second distribution we have, which is Poisson distribution. Poisson distribution has one parameter, which is lambda. So what is lambda? Lambda is the average number of success event in an interval. Let's look at the example we have here. If we want to generate 100 random numbers using Poisson distribution with lambda equal to 3.5, and we want to set the seed to 155. So first of all, we write the set dot seed. We start with 155. The next code is we need to write the code for generating random numbers, which is rpoise. And then inside rpoise, we need to write two information. One is how many numbers we want to generate. Second is what is the value of lambda we have. So lambda is here. This example is 3.5. Now, when you generate the random numbers, you need to highlight both codes together and run the. So now we have generated 100 numbers. Let's assume I want to display the 10th value of these generated random numbers. So how do we know what is the 10th value? You can just see it manually. What is the value you have in the 10th position, or you can just save your random numbers in the environment, run them again, so that y is saved as a Poisson random numbers. Now, whenever you recall y, you will get the same random numbers you have generated using Poisson. So if I want only to display the 10th value, this means I want to subset. I want to get the value of y at the 10th position. So y is a vector. I want to extract the 10th element of the vector y. So I'll get the value is equal to 3. You can check your answer manually also. We can see that the value of x is equal to 3. Now the last distribution is normal distribution. Normal distribution is a continuous distribution with two parameters. The first parameter is the mean. The second one is the standard deviation. Let's assume I want to generate 100 numbers using normal distribution with a mean of 50 and standard deviation of 10. This time, for example, I want to set the seed to 66. So first of all, set dot seed. That's very important. Then you have to use the command you have to use for generating random numbers using normal distribution. So the command is rnorm. How many numbers we want to generate, and then we need to enter the mean. If you just observe, when we are writing rnorm, then first of all we write the numbers, how many numbers we want to generate. If you don't write the value of the mean, the program will understand that the mean is equal to 0, standard deviation is equal to 1. That is the case when you are using standard normal distribution, which is Z. But in this case, we are using just a general normal distribution with a mean of 50. So mean equal to 50. And then standard deviation is equal to, in this example, the standard deviation is equal to 10. Let's run this code. So now we are getting 100 normal distribution, normal random numbers. Okay, so if I want to get the 35th value of your generated random numbers, you can save your random numbers with any name, for example, V. Then run the code. Now we need to extract the 35th element of B. So the 35th element of B is 35, 39.84818. Why we're getting here number with a decimal point? Because that is normal distribution, and normal distribution is a continuous distribution. Let's assume I want to generate random numbers using standard normal distribution. Standard normal distribution. When we say standard normal distribution, that is known as Z. And we know that Z has a mean always 0 and standard deviation of 1. So we don't need to write the value of the mean here with another different values. So whenever we say standard normal distribution, we should understand that it's Z. So let's create standard normal random numbers. So let's assume I will set the seed with a different value here, for example, 655. So set dot seed with 655, and then the code we use are norm with 100 numbers. We don't need to write what is the value of the mean. You can write. Otherwise, the program will understand that the mean is 0, the standard deviation is 1. So if you write like this, or if you don't write, see the numbers you got. Let's just remember the last number we got. Now let's observe what will happen if I don't write. If I don't write, I will get the same number, because by default, this program will understand if you're not writing any value for the mean, it will understand that the mean is 0 and the standard deviation is equal to 1. So we're getting the same numbers. We want to extract any value. For example, I want to find the 20th value or display the 20th value. You have to save these with any name, let's say Z. Then Z20 will get the value of Z on the position of 20th, which is 0.721587. So that's the same here we're getting. So that's the end of lesson 7. And lesson 7 was about how to generate random numbers. Thank you for watching.